Hi everybody, my name is Esmitt and my advisor are the professors Deborah Gil and Carlos Sanchez. The title of my research is VideoBronchoscopy correction using a 9 degrees of freedom tracking device. First of all, it's important to note what bronchoscopy is. It's a technique used by physicians in order to explore inside the lungs. For that, it's using some device called bronchoscope that is composed by a flexible tube with a camera attached here to capture the image inside the lung. Inside the lungs, there is like a labyrinth with several paths to follow, and the physician have to know which is the effective path to reach a lesion. That's the idea. So there is something called navigational bronchoscopy. It's like driving a car with a GPS system, which sounds great. However, not all bronchoscopy systems have this GPS. So we are developing a low-cost GPS system which could be added into traditional bronchoscopy. So with that, we have a position, a rotation of that bronchoscope in order to synchronize with our image in the VideoBronchoscopy, also in our 3D representation for our virtual bronchoscopy, which is a project that we are working to. So as we can see in the video, there is a movement with this device. This device is a sensor that is composed by three sensors more. The three sensors are gyroscope, accelerometer, and magnetometer. It's called 9 degrees of freedom because there is three values we can obtain for each one. Is X, Y, and Z. This is the position in 3D of one of them. There we can see how we can move this. And with that, it's important to correct and to calibrate this. So we use something called calibration semi-sphere, which is a 3D printed structure that we use to calibrate our device. This is our device here, which is connected to Arduino Uno. Here, this is connected to the computer, and this is the bronchoscope, and this is the flexible tube. It will be at this device here. So we use this calibration semi-sphere to get the proper calibration, because inside the lungs the distance are measured in millimeters, which is very important to know that. And normal GPS system is error is in meters, so in our case it will be in millimeters. That's a challenge here that we are working. So that's, as I mentioned, that's the most important challenge here. Is the short movement are not precise given the EMU values. EMU is the exact name of that device, is inertial measuring unit. So bronchoscopy exploration and measuring millimeters, that's our we are working, and that's the applying several algorithms in order to correct this. That's why we are using this calibration semi-sphere, and we are challenged of this. Working very hard on that. First of all, we apply correction using quaternions, using some stabilization algorithms. Also, we are working on trying to reduce also the size and the power consumption of our device from 9 degrees to 6 degrees, just to less and better for us. Also, we know that the initial calibration, is strongly impact in the value of the rotation. The calibration is the same calibration that we use when our GPS and our phones doesn't work. We move like this moving like an 8 or like infinite. So, well, my personal challenge is complete my knowledge in medical imaging. Also extend my knowledge in code optimization. That's right now with this project is we need a lot of code optimization, and well, survive to the next pandemics to come. Well, thank you very much. Bye.